Okay, now I'm looking at page 2 of the notes on properties of definite integrals. This kind of problem you see a lot. You're given an integral, you're given the value of the integral from 0 to 3 is 6, and the integral from 3 to 7 is -8, and you're going to use that using some of the properties we just talked about. I'm probably not going to go through all of these, but this one, for instance, the integral from 3 to 0 of f of x dx. Well, we know, first of all, they gave us the integral from 0 to 3, so we know the integral from 3 to 0, we just reverse the numbers, is just going to be negative integral from 0 to 3 of f of x dx. And so that's going to equal negative whatever this thing is equal to, which they tell us right here is 6. So we get -6. Okay, this one here, we don't know the integral from 0 to 7. They don't give it to us, but they give us the integral, the value of the integral from 0 to 3, and the value of the integral from 3 to 7. So we know that from 0 to 7 is equal to the integral from 0 to 3 of f of x dx plus the integral from 3 to 7 of f of x dx. Well, this from 0 to 3 is equal to 6. This from 3 to 7 is equal to -8. So we end up with -2 as our final answer. From 3 to 3, our integral, well, we know that was our first property, that the integral from a to a is always equal to 0. Again, here we have reverse the numbers. We've got a couple things here. We've got a reverse of the numbers, and we've got an extra 3 in there. So we can say that's equal to 3, and then because we've reversed the numbers, it's going to be -3. Integral from 3 to 7, integral from 3 to 7 of f of x dx. So we get -3 times what we were told before. The integral from 3 to 7 is -8, so -3 times -8, which is positive 24. And I think that's about all I'm going to do with this page. Oh no, actually I'll just do this. Okay, so right here we've got the integral from 3 to 7 of 2 times 3 f of x dx. Well, I know that's equal to the integral, and I'll write this all out. You probably wouldn't if you were doing it. 2 dx plus 3 times the integral from 3 to 7 of f of x dx. So all I did was break it up into like all of its parts. So with this, the antiderivative of 2 is 2x. So I've got the 2x from 3 to 7 plus 3 times -8, because I know this here is equal to -8. They told me that. All right, so that gives me 14 minus 6 minus 24. It's 14 minus 6. It's about 8. 8 minus 24 is, I think it's -16. You can check that. Okay. Over here, we've got an even function. Now remember, even function means it looks maybe something like, here's my axis, here's my y-axis. It looks something like that. Like a parabola is an even function. Well, parabola with its vertex on the y-axis is an even function. So, I know that this is equal to 2 times the integral from 0 to 3 of f of x dx, right? Because going from -3 to 3, this whole area under the curve is going to equal twice this area on the right. And I happen to know that that area on the right is 6, because they told me at the beginning that the integral from 0 to 3 of f of x dx is 6, so I end up with 12. This side 6, this side 6. Easy enough. Okay, last one. It's an odd function, so that means it looks like, maybe it looks something like this. It's got rotational symmetry around the origin. If I'm going from -3 over here to 3 over here, it doesn't matter that this is 6. I happen to know it's 6, and I happen to know that this is -6, but it doesn't matter because they're going to be the same. The whole thing is going to equal 0 because one's going to be negative and one's going to be positive. All right, so that's page 2 of the 6.4 notes on properties of definite integrals.